Okay, so we have to identify which substance will be a solid at 20 and melt in a beaker of hot water at 80. So the best way to this is to draw a number line for each of the samples we've got here, and on each one mark out the melting point and then the boiling point, as you can see. And then what I've done is mark on 20 and 80 so I can see what's going to happen. So if we look at this first one, I'm going to pick a different colour pen. If we look at this first one here, we can see that before it melts it's going to be a solid, and then it's going to be a liquid, and then it'll be a gas after it's boiled. So this one doesn't work because the 20 and 80 are both in this point here where it's going to be in a solid state, so it's not yet melted. Okay, next one, it's going to be a solid before it melts, then it'll be a liquid, and then it'll be a gas. So again, this one, let's go with that for a minute. B is not going to be correct because at 80 degrees, B is going to be a gas, and that isn't fitting in with the description we have got, so it's not B. Let's try C. C is going to be a solid up to here, so that's right, at 20 degrees. Then it's going to melt at 30, and then it's going to be a liquid, so 80 degrees it will have melted, so that fits in because it only boils at 2403. So C is looking correct. Let's just double check it with D. And as you can see here, it's going to be a solid, then a liquid, then a gas. So again, doesn't fit with the description because it's going to be a liquid in this region and a gas at 80 degrees, and that doesn't fit. So the only sensible option, so what we have here, we've got seawater and it's been heated, and we need to explain how we separate to produce pure water in the apparatus. So what's going to happen is we will heat the seawater, okay, and when we heat the seawater, the water will start to evaporate, okay, and it will evaporate and it will rise up the tube here, and the idea is along this tube it will start to condense, so the water vapor will condense. So by the time it gets to this point here, we have got liquid water. So we'll put there to form liquid water, and that's how. Okay, so this one is asking you to think about a process called simple distillation. And it wants us to say how we could improve the apparatus to get an increased amount of pure water. So you might remember doing this way back in year 10, and one of the problems was the steam kind of rises in here as we heat this up, and the steam will come through the side arm, and the idea is it's going to condense inside the test tube here, but what ends up happening is a lot of the steam comes out here without condensing and we lose the water. So the best way to fix this is to place a condenser. So use a condenser rather than just a side arm into a test tube, and a condenser is a more effective way to cool and condense the steam, the vapor, to produce pure water. So here we have a material, it's been heated and the temperature is taken every minute, and we get this heating curve. So here it starts with a solid and it increases in temperature until it gets to this point where it's melting point. Temperature stays the same, and then once it's completely melted, we get an increase in temperature. This state is in a liquid, and at this point here, it's in a solid state. So to help me think about this, I've drawn the arrangement of particles in a solid state, so they're packed together in rows, and all they can do is vibrate in terms of movement. And then I've got my liquid state, so my particles are more randomly arranged. The space between the particles and the particles are able to move past each other in the liquid state. So in terms of my answer, there are 4 marks available, so let's look at the stages. So if I go from A to B, that's when it's in this solid state. and the particles are close together and they vibrate around fixed positions. As we go to the flat part, that's B to C, this is where the substance is melting. And what the particles do here, the particles use energy to overcome any forces of attraction between them, and that starts to make them move further apart from each other as they start to melt. The final stage is C to D, and here the particles now are free to move past each other and they've got more energy, so therefore they can move